An atom is the smallest particle that still retains the characteristics of the element it's taken from, and is so small it can't be seen with today's most powerful microscopes. The center of the atom is called the nucleus and is made up of positively charged particles called protons and uncharged particles called neutrons. Negatively charged particles called electrons occupy the space surrounding the nucleus and make up most of the volume of the atom. The defining characteristic of the atoms of any one element is the number of protons in the nucleus. Carbon, for example, always has 6 protons, and any atom with exactly 6 protons in the nucleus must be a carbon atom. The number of protons in the nucleus is called the atomic number. The atomic number of carbon is thus 6. The atomic weight of an atom is the sum of the number of protons and neutrons in the nucleus. In the case of carbon, with 6 protons and 6 neutrons, the atomic weight of carbon is 12. All atoms of a given element have the same number of protons in the nucleus, but the number of neutrons may vary. Atoms that are of the same element but contain varying numbers of neutrons in the nucleus are called isotopes of that element. The atomic weight of an element is generally given in tables as a whole number with decimals, the result of averaging together the atomic weights of the principal or most common isotopes. When the same number of electrons surround the atom as protons in the nucleus, the atom is said to be stable. If an electron is removed or added to the outer shell, the charges are no longer balanced, and the atom is called an ion. Of the 3 fundamental particles, protons, neutrons, and electrons, the electron is the key in understanding basic chemistry. During chemical reactions, the nucleus of an atom remains unchanged. Only the electrons of atoms in the outermost shell interact. The elements are arranged according to the number of electron shells they have and according to similarities of chemical properties. This periodic table has horizontal rows called periods and vertical columns called groups. Elements of the same period have the same number of electron shells. Elements in the same group have similar chemical properties. Groups are important because the elements within groups tend to have similar chemical properties. For example, chlorine and iodine, both used for disinfecting water, are in the same chemical group. The 4 basic kinds of information included in almost all periodic tables are the atomic weight, the element symbol, element name, and atomic number. There are more than 100 elements known, 92 occur naturally, and the others have been produced in the laboratory.